Okay, some surds next up. Part A is rationalizing the denominator. We don't like surds on the bottom. So to rationalize the denominator, we write the original surd as it was. And then we multiply by the same as the bottom, but with the sign flipped around. So that's going to be the same on the top and the bottom. So 3 root 2 minus 11 over 3 root 2 minus 11. Because in doing so, I'm not changing the answer of the sum because this second fraction is just 1. You can think of this like double brackets. So FOIL, whichever method you want, 4 root 2 times 3 root 2, well 4 times 3 is 12, and then we times it by 2 to give us 24. Then 4 root 2 times minus root 11, it's a minus, first of all, it's minus 4 root 22. Minus root 11 times 3 root 2 is minus 3 root 22. And then minus times a minus is a plus for the final. So minus root 11 times minus root 11 is 11. All over. Now on the bottom, the quicker you get with these, the more you know that this is going to be difference of 2 squares. So essentially just square the first, square the last. But if we do need to do the full FOIL, 3 root 2 times 3 root 2 is 9 times 2, which is 18. Then we have 3 root 2 times minus root 11, which is minus 3 root 22. In the middle, root 11 times plus 3 root 2, so it's plus 3 root 22, which is what we wanted. And then a positive times a negative, and then the root 11s cancel out to give us 11. There's a fair bit of simplifying I can do here. Most importantly, the surds disappear on the bottom, which is what I want, so the bottom ends up just being 7. And on the top, we have 33. For the, sorry, excuse me, no we don't, terrible mental maths, we have 35. Then we have minus 4 root 22, minus 7 root 22. If we collect things together, we can certainly divide that through by 7 to give us 5 minus root 22. Okay, part B. A bit different this one. We just have some, I guess, some fractions knowledge that we need to know, and also how to cube a fraction. So if I'm adding these two together, we'll deal with that in a moment. We'll just simplify the second fraction first. We have 7 over 2 root 14 plus. Now, when you are cubing a fraction, you cube the top and you cube the bottom. So the bottom becomes 8. At the top, we have root 14 times root 14, which first of all is 14, then times another root 14. So that is what you get when you cube the top. Now, fractions with different denominators, bad news. So we need to make them a common denominator. And we get that by timesing the two denominators together to give us 16 root 14. Then we do the top of the first one times the bottom of the second one, plus the top of the second one times the bottom of the first one. So that is 14 times 2 is 28. And then the root 14s cancel out, and 28 times 14 ends up being 392. That there. But even when we get to this stage, don't like that because there's a surd on the bottom. Now you can get rid of that surd on the bottom if you multiply through by 16 root 14 over 16 root 14, the same denominator on the top and the bottom. Now this is like a bracket times by something on the outside. So some large numbers here, 56. Maybe I could have simplified, I don't know. Looking at that, yeah, maybe 8 would have gone into them, but I'm going to stick with this. Now we'll simplify at the end. So we have 56 times 16 on the outside, which is 896. 896 root 14. And then we have 392 times 16, big numbers, plus 6272 root 14 over. Now on the bottom, the surds will cancel out, but we have also 16 times 16, and then we have to times that by 14. We have 3584. They are ridiculous numbers. I'm going to check on the mark scheme how that cancels down to save me a bit of time. So oops, excuse me, I've come back a tiny bit too early. Yeah, the mark scheme makes me feel like a bit of an idiot because if you were to add these two together on the top, it might be a little bit more obvious what it comes to, because these two, obviously root 14s, you can combine them together. You end up with 2 root 14 at the end. It ends up working out very, very nicely.